Welcome to this video that will go over the solution to this first activity in the Part A lecture notebook for Module 4 in Computational Applications. In this activity, you were asked to play with the bisection algorithm. So there's 3 notes that you should read carefully. You should read all the instructions carefully. Note 1, you may want to or need to create additional code and markdown cells below as you work your way through this activity. The second note, you will probably need to explore some plots of the functions first. For example, by experimenting with the plot tool attribute of instantiations of the bisection class to determine viable candidates for the values of a and b in order to capture the root for the functions you are playing with. Suppose the root is 100, then you need to set up the problem and any associated plots around this value to get things to work properly. Third note, it is okay to show examples that produce errors. It is in fact encouraged that you do this as long as you explain the errors, for instance in code comments or markdown cells. Markdown cells are perhaps preferred because sometimes it's easy to skip over a code comment when we're grading and looking at this thing quickly. But you should also show results that do not produce errors. This is important. In this activity, and in fact always, you should look at reading some to mean at least 2. And this is what you should do. Create instantiations of the bisection class for some, again meaning at least 2 lambda functions of your choosing that have roots. So you could produce some that do not and that produce errors, but you need to explain that that's what you're showing. But you need to have at least 2 that do have roots. You need to demonstrate approximations of these roots for each lambda function using the plot bisection method attribute of the associated instantiation of that class, the bisection class. At least one of these plots should be without widgets, and at least one of these plots should use widgets for interactivity. And I want you to summarize results in a markdown cell you create below the plots. So do some plotting, and then summarize what's happening in a markdown cell. So you'll probably have to create a cell, make it a markdown cell, and summarize. Now for this, you can use what was done above as an example. This is showing how I created an instantiation of the class, right? So I created a bisection class for a particular function. Change functions. You create new functions. You can choose new polynomials, trig functions, whatever you'd like. Combinations of them. Be creative. Look at a few. Create instantiations. Make sure to use different variable names for them so you're not overwriting. And you can just pass lambda functions directly into this and say f1, f2, f3, whatever you want as this part of the code. Like you could copy and paste, in fact, like this code cell, and this code cell with interactivity below, and then just do it several times with different functions and show what's going on. Just I want you to play with the code a little bit. So there's not much for me to show here because I've already shown it in the notebook. You're basically following that procedure. I just want you to play with this with different functions. Now, one thing I want you to notice is that the method attribute plot bisection does not have tall underscore interval or tall underscore f, the interval tolerance or the function tolerance as parameters. When it calls compute bisection, it is simply relying upon default values for these tolerance parameters. We should improve upon that. You need to copy and paste the bisection class below and rename it bisection improved. So I will show you exactly what to do here. So here is this bisection class right here. So I know it looks long. So it's this class bisection. So you can just Control A, Control C, different if you're on a Mac, but I'm on a Linux machine here, or a Windows machine would also do that. Control A for select all, Control C for copy, unless you've changed your hotkeys. I paste all of this here, so I know it's a lot of material. And now let's just go ahead and look back up here. I want you to update the plot bisection method. Well, first I should say rename this bisection improved. Bisection improved. There we go. It's the improved bisection method. Go to the plot bisection method attribute, and that would be right here. Here's the plot bisection method attribute. And what I want you to do is, read it again. Allows all of the parameters in the set bisections parameters method to be set by the user. So notice these parameters can be set by the user. These tolerance interval tolerance and the set bisection parameters. But when we call plot bisection, when we look at plot bisection, we see the A and the B, right? We're seeing some of these parameters here, right? Again, let's go to here. A, B, N, but we don't see tall interval and tall F as being called in the, I think I scrolled too far, excuse me. And this, we see A, B, and N, and then it just uses everything else. And so when you call this, notice the tolerance parameters are not being called. So everything's keyworded here. So depending on where, you can add this wherever you want. You could do this at the end. You could do tall interval equals none, none. Tall f equals none. And then you could just pass this tall interval equals tall interval, whatever this is. So it might be passing a none type if you didn't set it, but at least you can now. And similarly, tall f equals tall f. That's it. This improves this class. It adds some additional functionality because it allows us to pass these parameters into the set bisection parameters when we're calling plot bisection. If we so choose, if we want to see what happens with the bisection algorithm as we vary these tolerance parameters, it's now possible to do it in the plotting directly. Before we didn't have that functionality, now we do. And you might want to also update this code comment. In fact, I would do that with any new A, B, N, tall interval, or tall f values. There you go. That's it. That's all I'm asking you to do in this part of it. Is this requires just updating a few things, the parameters passed to that plot bisection, and then the call to the bisection parameters within this method. And then finally, I know it's a long class, we have to scroll. I want you to redo the first part of this activity using the bisection improve class for some lambda functions, again, meaning at least 2, with and without widgets, and where you show results for the different choices of these new tolerance parameters. You should use a float log slider for the tolerance parameters, since we often vary tolerance parameters by orders of magnitude when we are testing out an algorithm. So this part, again, I'm not going to show, but what I suggested you basically copy and paste and edit for new functions here. You could copy and paste those below, except below this, again, a lot of scrolling. I'm sorry, it's a long class. There's a lot of functionality in there. You could put all that material here, except when instead of calling the bisection class when you instantiate the object, so like this, instead of this, you would say bisection improved. And then when you do the plotting, one of the things I suggest, without interactivity, you could just leave it like this. But with the interactivity here, you should use a float log slider. You might want to look up what that is with the widgets. And you want to make sure to pass to those for the tall f and tall interval within this interact manual widget. So you just want to add those arguments in here when this is based on the improved plot bisection or the improved bisection class. That's it. That's all you have to do for this activity. So good luck. I hope this helps. Thanks for listening.